I want to talk about assigning oxidation states to elements in compounds. And there's a few rules that we need to follow when we do this. First, the oxidation state of all elements in a compound must add up to the charge on that element. It should say on that element or compound. So let's add on that element or compound. Magnesium, for instance, Mn, if you have just Mn with no charge on it, the oxidation state of that manganese metal must be 0. While if you have the Mn plus 2 ion, it has an oxidation state of plus 2. In Br2, since the total charge on this is 0, both Br atoms must have an oxidation state of 0 for it to add up to 0. On the other hand, in NaBr, you have an Na plus 1 and a Br minus 1. And again, those two add up to 0. The next thing we need to remember is that elements always form ions with oxidation states consistent with the table below. And we've talked about this table before and the patterns and the trends that are in that table. There are a couple of exceptions to this, particularly in the case of compounds that contain oxygen. In all of the examples that we're going to look at this semester, oxygen is going to have a minus 2 charge on it. There are only a few exceptions to that, and we're not going to worry about it too much. In this case, as I said, oxygen has a minus 2 charge on it, and the oxidation state of the other nonmetals is inferred from this, and we'll talk about how we do that in a minute. There is one exception to that when we have compounds that have both oxygen and fluorine, but we're not going to worry about that either. So let's look at some examples. Na with no charge on it. The charge is 0 on the element, so the oxidation state of Na is 0. For NaOCl, sodium in a compound, we look at our chart and Na must be plus 1. We've got oxygen and chlorine in this compound. The oxygen is always going to be minus 2. Minus 2 and plus 1 from the sodium add up to a negative 2. In order for everything to add up to 0, the chlorine must have a plus 1. So Na plus 1, O minus 2, chlorine plus 1 add up to 0. If we look at the next example, NO3 minus 1, and that's not as clear as I would like it to be, so let me fix that a little. Why are you not cooperating? There's an extra line there. NO3 minus 1, we know that the charges on everything have to add up to minus 1. We also know that oxygen is always going to have an oxidation state of minus 2. There are 3 of them. That gives us a total of 3 times 2, or negative 6 charges. In order for this to add up to minus 1, the nitrogen must be plus 5. Minus 6 and plus 5 add up to minus 1. Keep in mind that the oxidation state on the oxygen is minus 2, not minus 6. That's a mistake people make a lot of times. The oxidation state on oxygen is minus 2, and we have 3 of them, each with a minus 2. In the last example, K2PO4, the potassium, according to our chart, is going to be plus 1. Oxygen is always going to be minus 2. And we've got 2 plus 1s, that's a plus 2. We've got 4 minus 2s for a minus 8. The minus 8 and the plus 2 add up to minus 6. So the phosphorus has to be plus 6 for everything to add up to the charge on the compound, which is 0.